us close and well connected with each other. But it is all possible because of giant network of computers and devices which makes internet available all the times. Computer network is basically a group of computers or devices like mobile phones that are linked together through a communication medium like cables, satellites to communicate or share the resources like printer, CD, files and services. In modern times, a computer network is essential for the success of an organization. Within an organization, it is created to provide a means of transmitting crucial data such as money transaction or confidential data from one computer to the another. In general, the important benefit of computer networks could be file sharing. Networking of computers helps the user to share data files. Hardware sharing, users can share devices such as printers, scanner, CD-ROM, drives and hard drives, etc. Application sharing. Applications can be shared over the network and this allows implementing client-server applications. User communication. Networks allow users to communicate using email, news groups and video conferencing, etc. Network gaming. Lots of games are available online which can be played by multiple users simultaneously. In brief, it is hard to imagine the world without emails, online newspapers, videos, blogs, chat and other services like social networking, online shopping, reservation, etc. offered by the internet. Based on connectivity medium, we can classify computer networks into two categories: wired network and wireless network. In a typical wired network, twisted pair cable, coaxial cable, optical fiber cable, etc. can be used as a communication medium. On the other hand, a wireless network may use radio waves or infrared signals for communication. A wired network is preferred for security and economical issue. A wireless network provides convenience and flexibility over a wired network in terms of geographical area covered. The network can be classified as a local area network (LAN), metropolitan area network (MAN), wide area network (WAN). A LAN basically connects a relatively small number of machines in a small geographical area like a room, building or a campus within an organization. For example, Ethernet is one of the most popular technologies preferred for a LAN. The communication infrastructures that have been developed in and around large cities is called as MAN. For example, voice communication services offered by a service provider in a city is an example of MAN. A network that links two or more local area networks over a potentially large geographic distance like countries is known as WAN. The internet, very common nowadays, is essentially a wide area network spanning the entire globe. There is another way of classifying network on the basis of connection established between a sender and receiver machine, client and server network and peer-to-peer network. In a typical client and server network, high-end server are used to serve clients by providing specific services on the client request. Each client machine communicates through a server machine. On other hand, in a peer-to-peer network, there is no dedicated server. Each machine is considered equally powerful. This network is suitable for home and small office.
Wired and wireless medium for communication. In a typical wired network, information exchange between devices takes place through cable media, whereas in wireless networks, radio waves or microwaves are used as transmission media. For cable media, widely used options available are twisted pair, coaxial cable and optical fiber cables. Twisted pair cable is the commonly used medium for all telecommunication. It consists of copper wires that are twisted into pairs. The use of two wires twisted together helps to reduce crosstalk and electromagnetic induction. The example of twisted pair cable is telephone wires. The typical transmission speed for twisted pair ranges between 10 to 1000 Mbps. It can transmit data at maximum rate up to 1 km without any loss of data. Two important varieties of twisted pair cables are category 3 and category 5. Coaxial cable is extensively used for cable television systems, office buildings and other work sites for local area networks. The cables consist of copper or aluminum wire as core. The core is surrounded by an insulating layer, typically a flexible material with a high dielectric constant, which itself is surrounded by a conductive layer. This insulation minimizes interference and distortion in the transmitted signal. The typical transmission speed ranges between 1 to 2 Gbps. It can transmit data at maximum rate up to 100 km without any loss of data. A coaxial cable can be broadly divided as baseband and broadband cables. Data transmission takes place using pulses of light passed through an optical fiber. Optical fiber offers a lot of advantages over metal wires, such as low transmission loss, better immunity towards electromagnetic radiation and offering fast transmission speed up to 100 Gbps. It can transmit data at maximum rate up to 50 km without any loss of data. An optical fiber can work in single or multi modes. The comparison among various cable media is shown in this table. For wireless transmission, widely used options are infrared, radio waves and microwaves. Infrared waves are used as wireless transmission medium for communication between devices placed at short range of up to 10 to 15 meter approximately. However, infrared waves cannot pass through a solid object like wall. A TV remote uses infrared waves for communication. Radio waves are used for wireless communication between devices. Radio waves can travel in any direction, hence transmitter and receiver need not to be aligned carefully. The example networks are mobile networks and Bluetooth. Microwaves offer more bandwidth in comparison to radio waves. However, in comparison to radio waves, in microwave communication, a transmitter and receiver should be aligned carefully. It is widely used in satellite networks. In addition to physical communications media, network also comprises of additional basic hardware devices such as network interface cards, repeaters, hubs, bridges, switches, routers and firewalls. A network interface card, which is also known as NIC, is the essential hardware required to connect a computer to a network. It consists of a unique Ethernet media access control address, which is also known as MAC address, which can be used to distinguish two computers on a network. The size of an Ethernet MAC address is 48 bits and divided into 6 octets. The three most significant octets are reserved to identify a card manufacturer and the rest 3 octets are uniquely assigned to each NIC. A repeater is a network device that receives a network signal as input, removes the noise and regenerates the signal. It can be used to send signals where long distance cables are required without degrading signals. The regeneration of signals may cause propagation delay, which can affect network performance. A hub is basically multi-port repeater. However, repeaters and hubs have been mostly replaced by modern switches. A network bridge connects multiple network segments to form a single network. It examines a frame received on the port and forwards it on the destination port according to binding of port and MAC address maintained in the bridge. Moreover, when a bridge receives an unknown MAC address, it starts discovering the port on which the MAC address is available and update the binding accordingly. A network switch enables other network devices within a network to talk with each other. Switches decide about where to forward frames based on destination MAC addresses. Switches use point-to-point connection for communication, whereas hub uses broadcast mode for communication. A router is an inter-networking device that forwards packets between two or more networks. A router contains routing information which is used by the router to forward a packet to its destination network. A firewall is a network device used for the purpose of network security and controlled access. Firewalls generally prevent an organization's network from outside or public network by blocking unauthorized connection requests.
The network topology defines the method by which various network components such as computers, printers and other devices are connected with each other. In other words, we can say that a network topology illustrates the outline of the link and devices as well as the paths used by data transmissions. The different types of layout of network topologies are bus topology, star topology, ring topology and mesh topology. In bus topology, all nodes like workstations, printers, laptops, servers, etc. are connected through single communication line that carries messages. In bus topology, the transmitted signal travels the cable length in both directions from the sending computer. When the signal reaches at the end of the cable length, it reflects back in the transmitted signal direction. This is known as signal bounce, which creates the problem of collision in the network if another signal is sent on the cable length at the same time. To prevent this signal bounce, terminators are used at the end of backbone cable. Advantages of bus topology: easy to configure because computer or peripheral can be connected easily to a linear bus. Requires less cable length than other topology like star topology, hence it is relatively inexpensive. For a small network, it works well. Disadvantages of bus topology: entire network shuts down if there is a break in the main cable. To prevent signal bounce, terminators are required at both ends of the backbone cable, which result in added cost. Difficult to troubleshoot means it is hard to identify the fault location if the entire network shut down. It cannot be used as a stand-alone solution. Star topology is the most commonly used topology in LANs. In this topology, each node is connected directly to a central network hub or switch. Each workstation has a cable that goes from the network card to network hub. The star topology resembles with the spokes in a bicycle wheel. Advantages of star topology: it is easy to install. If a device is connected or removed from the network, it will not affect the functioning of network. It is more fault tolerant than bus topology. Fault detection is easy. It offers opportunities for expansion to network designer. Disadvantages of star topology: it requires more cable than a linear topology like bus topology. The overall functioning of the network depends upon the working of central unit or hub. If the hub fails, nodes attached to it are disabled. More expensive than bus topologies because of the cost of the devices. In a ring topology, each computer is connected to the two nearest nodes via a cable such that the entire network form a circle or ring. This ring has no starting and ending point, hence terminators are not necessary like bus topology. In ring topology, signal travels in one direction around a circle, stopping at each node. If a node wants to transfer the data, it adds the data and the destination address to the initial transmitted signal. In this process, each node also participates in signal regeneration so that it may travel the required distance. The regeneration of signal is the process in which a weak signal is recovered to its original characteristics. Advantages: signal degradation is very low, since in this each workstation is participating in the network for regenerating the weak signal. Disadvantages: requires more cable and network equipment at the start. Not used as widely as bus topology. If one workstation fails, entire network will fail. In mesh topology, all nodes are connected to one another. It is widely used in WANs to interconnect LANs. It can further be divided into two categories, namely full mesh and partial mesh topologies based on the degree of connectivity of each node. In full mesh topology, each node is connected to every other node of the network, while in partial mesh topology, each node may or may not be connected to every other node of the network. Advantages: it supports simultaneous transmission and can withstand high traffic. Better adaptable to faults as alternative routes exist between two nodes. It supports good scalability in form of introducing new nodes and removal of a node can be done smoothly without disrupting other nodes. Disadvantages: it is difficult and complex to implement because of cabling infrastructure. It is difficult to manage due to its complexity. It is expensive since extra cables are required to form the